This is the second of our trigonometry reviews for Algebra 2 as we start to get ready for the MCAs and the ACTs. And trigonometry involves our understanding again that we're using SOHCAHTOA. And in this case, we're going to talk strictly about right triangle trigonometry to find the missing pieces of a triangle. So number one, the instructions say find the value of x round to the nearest tenth. And what I want to do is focus on the non-right angle that they give me, which is the 33 degree angle. And then think about all of the labels that we have in SOHCAHTOA: opposite, adjacent, and hypotenuse. And I want to label the two pieces of information that they gave me about the sides. So if this is my 33 degree angle right here, then this x, that's as far away as I can get from it in that triangle, and that makes it the opposite side. And the 14 is the angle that's opposite the right angle, so that makes that the hypotenuse. So I look up at my SOHCAHTOA and I try to figure out which of those trig functions is going to have just opposite and hypotenuse. And that's going to be sine. So the sine of 33 degrees equals opposite x over hypotenuse 14. Now what I need to do is remember that the sine of 33 degrees is a number. It is a number that is stored in my calculator. So if I want to get x all by itself and it's being divided by 14, what I have to do is multiply both sides by 14. And again, that number is stored in my calculator and it's just waiting for me whenever I need it. So I noticed the directions said round to the nearest tenth. And what we would want to do, especially on the MCAs or the ACTs, is make sure that your calculator is going to be set to the degree mode. And that's because there are different measurements that we use for angles, and just one of them is degrees. So we go into mode, and we come down to where it says radians. And we notice this one was already in degree mode. It's already been highlighted. But we absolutely need to check that when we're going to be testing. If they give us something in degrees, we want to make sure the calculator is set in degree mode. And I'm going to go back to the main screen. And what we wanted to find out was what is 14 times the sine of 33 degrees. And they said to the nearest tenth. So we would look at the 2 in this position, in the hundredths position, and say since that's a 2, that is a number that's less than 5, so we would round down. So our answer would be 7.6, approximately 7.6. And that's why I have the wavy equals bars here, and that's because this is approximately because we were rounding. Now when wouldn't you use those? There is the special right triangles that we had talked about on the last video with the 30, 60, 90 and the 45, 45, 90. And those would be trigonometric functions that we can find exact using our special triangles. Now I look at number 2 and I see that my angle is 37 degrees. So I already have my calculator in that degree mode, which is great. And then I need to put my labels on this triangle. Well, my 14 is my hypotenuse. It's opposite the right angle. But I'm not using that opposite side anymore, and that means I'm using an adjacent side, and adjacent means right next to. So the x is right next to the 37 degrees. And I see that I'm going to use adjacent and hypotenuse, and I realize I'm not going to use sine this time. I'm going to use cosine with adjacent and hypotenuse. So the cosine of 37 degrees equals adjacent x over 14 hypotenuse. And then what we'll need to do, because again the calculator is storing that cosine of 37 degrees for us, is just multiply both sides by 14. So 14 times the cosine of 37 degrees will give us x. And again, we're going to use a calculator and we're going to get this approximately because 37 degrees is not a special measurement that we have in our right triangles. And keep in mind that we want to round this to tenths. So 14 times the cosine of 37 degrees I know that I already have this in the degree mode, so I will get the answer here, and this time we look to the hundredths position and we see an 8. And 8 is 5 or larger, so we need to round up. This would be 11.2 for our answer, approximately 11.2. Already we've seen an example where we needed to use sine and an example where we needed to use cosine. And of course, you know, we might come across something occasionally where we need to use tangent. It's all about what we need and what we want. And because of that, I'm going to go ahead and put an X right here on this one and force us to use that last piece that we have not used from SOHCAHTOA. So if this is 68 degrees, my 6 is opposite that 68. It's as far away as you can get from it. And then my X, that's actually the adjacent side, because the one that doesn't have anything on it is the hypotenuse. So I notice I'm going to use opposite and adjacent, which would be tangent. So the tangent of 68 degrees equals opposite 6 over adjacent X. And this is a really interesting predicament we have here, because what we're trying to find is X, and it's in the denominator, and we can't leave that down there. Whenever you're trying to solve for something, you can't leave it in the denominator. So the first thing we're going to have to do is multiply both sides by X just to get that out of the denominator. Now, if I want X all by itself, I have to get rid of the tangent of 68 degrees. So how do I get rid of it? Well, it's just a number. So I'm going to divide both sides by the tangent of 68 degrees, because right now it's being multiplied. So we will need 6 divided by the tangent of 68 degrees. And again, my calculator is already in degree mode, so it's just a matter of punching it in and then doing a little bit of rounding. 6 divided by the tangent of 68 degrees. And we look to that third position here, which would be 2 decimal places back, and we see that there's a 2, and then we would round down. So that will be approximately 2.4. So all of these were really good examples of the uses that we have for SOHCAHTOA when we have missing pieces in a triangle. But of course there might be a word problem or two, because all of the MCAs and the ACTs are going to be word problems. And 4 says an escalator at a shopping center is 200 feet 9 inches long, and it rises at an angle of 15 degrees. What is the vertical rise of the escalator? And round to the nearest inch. So, escalator looks something like this, and of course that's going to form my right angle. And it says it's 900 feet 9 inches long, but I notice in the answer they want us to give this to the nearest inch. So the first thing we would want to do is convert that 200 feet into inches by taking that times 12. So we would get 2,400 inches, and then we'd have to add the 9 inches that we already have. Now that's the length of the escalator. So from here to here is 2,409 inches. What next? Well, now we need to figure out where this 15 degrees is going to go. So it says it rises at an angle of 15 degrees. Well, as you are on the escalator, you are rising. So that angle right there is going to be 15 degrees. They want to know what the vertical rise of the escalator is. Well, vertical is up and down. So that is going to be the vertical rise of the escalator. And what we need to do again is to label our sides so that we can see which trig function to use. If this is the 15, then this is the opposite. And of course this, the escalator itself, would be the hypotenuse. Opposite in hypotenuse is sine. The sine of 15 degrees equals x over 2,409. And just like we did on the last page, we're going to multiply in order to get x by itself. And again, we might need to do a little rounding because this one is the sine of 15 degrees, which is not something that's going to come out perfect. So we need to punch in 2,409 times the sine of 15 degrees and see what we get. So 2,409 times the sine of 15 degrees. 623.49507797. And this said to round to the nearest inch. So we're going to look in that tenths position, and we see that there's a 4 there. And that tells us we should round down. So that would be 623 inches. Right there. So one of the things you want to pay attention to on tests like these is having to convert the units. This one was in feet and inches, and our answer needed to be in inches. So we had to do a little converting to make that happen. Number 5 says a 12-foot long ladder. Okay. So here's our ladder. A 12-foot long ladder is leaning against a wall, a little building right there, and it makes a 77-degree angle with the ground. Well, there's my ground, so this is going to be 77 degrees. How high does the ladder reach on the wall? Okay, well, that's this height. And it says round to the nearest inch. So, once again, inches, feet. So we need to take 12 times 12 and get 144 inches to start off with. And that was the length of the ladder. So we look at this one and realize we're still using opposite, we're still using hypotenuse. That's going to be sine. The sine of 77 degrees equals x over 144. And again, if we want to get x all by itself, we're going to need to multiply. So we're going to multiply both sides by 144. And then we'll just go ahead and punch it in because, again, 77 degrees is not special. The special ones for our special right triangles are going to be 45, 30, and 60 degrees. So we need 144 times the sine of 77. And for this one, we wanted to round this to the nearest inch as well. So our tenths position there is a 3. We will round down, and that will be 140. And of course, we want to look at all the answers and make sure that they are rounded to that nearest inch. I can't really read that inches that I have right there. You know, don't get tricked into picking something that has the wrong label on it. You know, they might just put 140 feet as one of the answers. But then you'd also notice if you kept reading that 140 inches would be one of the answers that you have. So don't be tricked into those type of things. Those are called distractors by test writers. Then, these last couple of problems involve using trigonometry backwards to figure out what the angle is. So this one says find the value of x, round it to the nearest tenth. And I notice that's the angle this time, that's the degrees. But we still go about starting this the same way because we need to label the sides that are involved. And the sides in this triangle that are involved are opposite and adjacent. The hypotenuse doesn't have a number there, so we don't want to use that. And we think about SOHCAHTOA, and we realize that tangent, so the tangent of x degrees equals opposite over adjacent, 17 over 11. And then we have to remember, well, how do you get the calculator to work backwards to tell you what the angle is? Well, that is actually the inverse tangent key on your calculator. So this is where we use those second functions. And we're going to punch in second tangent. And we want to punch that in for 17 divided by 11. So this is telling the calculator we want it to work backwards and tell us what the angle would be that has a tangent of 17/11. And then we want this rounded to the nearest tenth. So we see that in the hundredths position we have a 9, and that is 5 or greater, so we're going to round up. So this would be approximately 57.1 degrees. And again, always making sure that we're in that degree mode when we start working with these. In number 7, I have a similar situation. Here's x. Straight across from it, which is opposite, we have a 12. Right next to it is a 29, and that's adjacent. And we don't have the hypotenuse. So this one just happens to be another problem where we would use inverse tangent. But know that you could use inverse cosine, you could use inverse sine. It's all about what sides are involved. So the tangent of x degrees equals opposite 12 over adjacent 29. And now what we would want to do is use that inverse tangent key and figure out what our angle is. So we need the inverse tangent of 12/29. So second tangent, 12 divided by 29. And we round to the nearest tenth. So we look at the hundredths position, which is a 7. And that tells us that we have to round up. So it will be 22.5 degrees approximately. Again, it just happened that these two examples used tangent, but go by the labels that you have for your sides when you're trying to figure out which of the inverse trig functions to use. Inverse cosine, inverse sine, and inverse tangent. And on this last page is the extra credit homework. What I need you to keep in mind is that you need to watch the video, then you need to go through and do the 6 problems that are on here. And once you've done that, if you do those problems correctly, you're going to get extra credit for this assignment. So with number 1, 2, and 3, you want to label your sides, and then you want to figure out which trig function you should use to set up an equation. For number 4, what you're going to want to do is read through the problem, draw a picture, and then figure out whether or not you need to do any conversions so that you can get everything to work in inches or feet or whatever it is, and use your trig to solve that. And then for 5 and 6, for these two, you're going to use your inverse trig functions to figure out which trig function you should use, but with the second button. And that's because we need the inverse trig functions to get the angles for 5 and 6. So let me scroll up one more time, and you can certainly just pause the video at this point and do problems 1 through 4. And now I will scroll up. And there are 5 and 6.